Okay, this video is on section 16.3, um, water acting as an acid and a base. And if you watch the other videos, amphoteric is one of those vocabulary words that you guys talked about in class yesterday, and it's talked about in this section of the book. I'm on page 390, but we're going to go into something called the ion product constant. And you guys didn't say you were having a hard time with this, but I seem to remember my kids having a hard time with this whenever I was teaching this subject. So we're just going to talk about it for a few minutes. Okay, so right now we're talking about pure water. Okay, so I'm not talking about that I have to take a beaker of water and add a beaker of water. Okay, I'm just talking about two water molecules floating around in a beaker of water. They happen to hit each other. Okay, so that's how these reactions take place. So two different water molecules. And what's going to happen here is when they hit each other with enough force, it is possible that this breaks off, this goes over here, and it forms an H3O plus and an OH minus. This doesn't happen very often. So this is a reversible reaction, and that's why you get these double arrows. So some of it goes over here, but most of it stays this way. Okay, so but in pure water, for every one hydronium ion, you're going to get one hydroxide ion. So this concentration are going to be equal, or these concentrations are going to be equal. Okay? And like I said, this reaction doesn't happen very often. So the impure water at 25 degrees Celsius, you change the temperature, you change the concentration, but we always deal with 25 degrees Celsius. It's pretty much room temperature. It's once you change the temperature, you kind of change everything a little bit. So we just always deal with this temperature. Okay, so it is also 1 times 10 to the negative 7. Moles per liter, if you guys actually didn't go into that. But anytime you deal with these brackets, it doesn't talk about this in the book, I don't think. Yes, it does. Okay, molarity. Anytime you see these brackets, that's the concentration in molarity, moles per liter. Okay, so this is not huge. Okay, but what's very interesting is it doesn't matter if you add an acid or a base, the constant stays the same. So meaning that the product, ion product constant, okay, we're talking about the product. This is the product. Okay, this is 1 times 10 to the negative 7, and this is 1 times 10 to the negative 7. And you multiply these out, it's 1 times 10 to the negative 14th. Again, moles per liter. It doesn't matter if you add an acid or a base, this constant stays the same. This is negative 14. I don't know if you can read that right here. Okay, so if this goes up, what has to happen to this one? This one has to go down because this is going to be the same. Okay, so that is how we go back and forth. That is how we know when we add hydronium ions to something or H plus ions, because the book will actually, to simplify it, it just simplifies it and turns it into an H plus because it's just water with an H plus. So you can write it either way. I would accept either way. I think the book goes back and forth, but ends on this right here. Is always going to equal 1 times 10 to the negative 14th. Okay, so for example, if I tell you the hydrogen ion concentration is 1 times 10 to the negative 3, the question asks, what is a hydroxide ion concentration? You know that the two have to multiply together to equal 1 times 10 to the negative 14th. So 1 times 10 to the negative 3rd times a hydroxide ion concentration equals 1 times 10 to the negative 14th. So you divide both sides by 1 times 10 to the negative 3rd, and you get the hydroxide ion concentration, which is going to be 1 times 10 to the negative 11th. You change this number here, and it doesn't make it quite so easy, because right now when this number is 1, you can just add and subtract your exponents. That's just your algebra 1. Okay, once you change that number, it's going to be much easier if you get a calculator out. But anyway, so that is always going to have to equal 1 times 10 to the negative 14th, and that is what allows you to always figure out one when you're given the other. And then from that, you can figure out your pH, and we'll make that into another video. But this is called, one of your vocabulary words is ion product constant. Ion product constant. It's one of those things you have to memorize. That is this. That is this. Okay? You need to memorize that these two have to equal 1 times 10 to the negative 14th. You have to be able to use it and recognize it as the ion product constant. Let me know if you have any questions.